because it's right there. I've got it in my phone. When I pull up the randomizer, it's Amoroso. So Gavin, if you're listening to this, I couldn't remember your last name. Sorry. Amoroso. Now I will remember for the rest of time. Okay, well, Claire, though, gets to do this. What's the antiderivative of cosine? It is sine. Yeah, it's super easy, right? So so that's what we get. So we do this. Let's see, this equals this equals this equals sine. Okay, it's almost done. What's the last thing I need? Sine of what? Sine of u plus what? Plus c. Yeah, don't forget the plus c. You lose a point on the next test. Very nice. And then the final step is to resubstitute. Resubstitute for u. So whatever u is up here, I'm going to just stick it in there. U is x cubed. It's going in there. This is equal, oops, change back to blue. This is going to equal to sine of x cubed plus c. I know that's not very exciting because we knew ahead of time that was going to be the answer. There you go. Okay, let me see if I can copy just the stuff that I want. Hold on a minute. I'm going to zoom out a bit. But yeah, if you have questions, I'm happy to answer them. First of all, let's get rid of this. Delete. Pretend that we don't know the answer to that. And then I'm going to copy this. Copy. And paste. Ooh. Uh-oh. Delete. There it is. There's my 6 steps. We're going to do this a little quicker. And eventually, we're going to get to worksheet number 2 and be able to enjoy that one as well. Okay, so let's go ahead and do these 6 steps. And I will number them. Number 1, identify u. It is the thing in parentheses. Who gets to do it? Raina. Raina, for letter I up here, what is u going to equal? This one right here, yeah. So what's in parentheses? Nothing. Yeah, there's an implied set of parentheses, though. So here, I'll put the implied set of parentheses. There. It is x to the 4th. Very good. So what you want to do is look for something that it may not be in parentheses literally like it was in the previous one, the cosine of x cubed. But here, there is an implied set of parentheses. And so there it is. Okay, so x to the 4th. That's my u. Very nice. So u is x to the 4th. Oh, what am I doing? Sorry, I just realized something's missing. Sorry, there's a typo. This should be dx right here. Super important for step 3. Yeah, so stick that x cubed there, or dx. Okay, next, step 2. Do the derivative. Du is equal to, what's the derivative of x to the 4th? Sam, do you know the derivative of x to the 4th? It is, very nice, 4x to the 3rd dx. Very good. Now comes the part that, like up here, no one would be angry at me for insisting on doing my algebra the way I did. Here's where students start getting mad. So if you're one of those students, it's okay. So here's what I'm going to do. I'm going to do this. I'm going to change. So number 3, notice what it says. Use algebra to isolate du. So I want this. You might say, wait, there's no 4 up there. Yeah, you're right. There is no 4. So I'm just going to magically make a 4 out of thin air. But of course, I'm a mathematician, so I can do this. But anyway, it's if you put the 4 here, you just have to balance it with a 1/4 somewhere. And so there it is. This is another shortcut trick that some students have learned from their teachers, is they skip this step and they just cut to the next step, which is the substitution, and they put the 1/4 in there, which is technically fine. I just want to be able to see the actual substitution so that when a student says, wait a minute, what happened to dx? I can say, we changed this whole thing into this. So, and I've had students who really get stuck on what's going on with the du and the dx. And so I want to make sure I help them And if you want to skip to the next step, that's totally fine. Here we go. So there's that. There's that. So I've done it. Now let me just make sure that the algebra hasn't blown anyone's mind. Yeah, what do you think, Jackson? That was one step I did, yes. Mm-hmm. That's correct, yes. So technically, I've kind of skipped a step myself. And so let me just, here's sort of the step that I skipped, is that 4 over 4 times x cubed is just x cubed. So that's 1 times x cubed. And then I took the 4 and I separated out the 1/4, and then I moved it. But yeah, I just did a little bit of algebra. And the algebra that everyone's uncomfortable with, though, is that one. Fabricating the 4 over 4. It feels like I'm doing magic. It is not magic. It's one of the rules of algebra. One of the rules of algebra is that when you multiply a number by 1, you get that number. 1 times anything is that number that you got to begin with. 1 times 10 is 10. 1 times 7 is 7. 1 times x is x. And so this is just another way of writing 1, and then I separate it into the fraction and so on. So that's the step that some students don't like, and it's fine. If you don't like it, you can, here, I'll even show you where to go if you don't like it. So there it is. But I really prefer I don't know, myself being regular about it. So we've done step 3, substitute for u and du. So you can see what I'm going to do for du. It's right here. The u here is just x to the 4th. Oh, I guess my arrow is kind of there. And then the 1/4 is just going along for the ride. So, like I said, some teachers, I know, because I've talked to students who are like, yeah, my teacher says just put the 1/4 out front. Here, we can do that. That's legal. All that teacher is doing is they're like, yeah, skip that step. But that step exists somewhere. And that's where the 1/4 came from. So anyway, that's the deal there. There are a couple other ways to execute this step 3, as I'm calling it, using algebra to isolate du. So if you're really uncomfortable with the way I'm doing this, and you don't know another way to do it, I can show you several other ways of using algebra to isolate du. That's fine, I can do it. I just don't want to, I want to be consistent when I'm standing here. So I'm always going to do it this way. Anyway, now at this point, everyone can do this, I'm sure. Let's see, who's next? You're not here, but Matt is. Matt, what do you think? What's the integral of e to the u? E to the u plus c. Very good. Look at that. We did step 5. Almost there. Final step, step 6, resubstitute. And put a box around it. Isn't that beautiful? It's so awesome. I mean, I love substitution, just sort of feels good. The only thing that's better than substitution is integration by parts. And we'll get there maybe. We'll see. It's so good. By the way, integration by parts is doing the product rule in reverse. Delete. There. All right, let's see if we can work through this one. This looks scary. I think you can handle it though. So we're going to do this quickly. Jared, what's in parentheses here? What am I going to use for u? All right. Excellent. Next, we're going to do the derivative of this thing. Colton, you can do the derivative of that, right? 4x cubed, and then don't forget the dx there. So I know this is, like I said, up top, this is really du over dx is 4x cubed, and then I move the dx over using the chain rule. But in general, this is good. Oh, and I left off my dx once again. Typo. Did I do the same here? No, I've got all my d's. Good. Okay, next, we're going to isolate. So this is the hard part. This is hard. You're using algebra. Algebra, once you know you've got to use algebra, it's hard. So Let's see if we can do this though. I'll do it slowly. Let's do this. 1/2 x to the 4th plus 3 to the 1/2 power times x cubed dx. That wasn't bad, was it? I just moved the x cubed over. Commutative law. We're good with that. Now, I'm not quite done. I need a 4. I'm going to do the same thing I did on the previous problem. So let's see, 1/2 times x to the 4th plus 3 to the 1/2 times 1/4 times 4x cubed dx. So once you see this a couple times, you're like, wait, why did you have to write it out like that? Well, I just want to write it out. I'll be quicker the next time. So this is 1/8 x to the 4th plus 3 to the 1/2 times 4x cubed dx. All right, so any quibbles with my algebra? I tried to write it out every little step, which makes it a little more tedious, and I realized that the camp of people who would just do the reciprocal of 4 and multiply would have gotten down here much quicker, but it might have been more mysterious as to where the 1/4 came from. All right, almost there. Now we substitute. So do the substitution. I'm going to substitute these two things. So we get, oh, why do I need 2 dx's? Let's go up here so that we can see everything. So it's 1/8 times u to the 1/2 power times du. That's it. You see where everything went? It all got substituted. This is just the chain rule in reverse. That's all it is. But it's just complicated because of the fact that you don't know what you're substituting for. All right, Jackson, you know the antiderivative of u to the 1/2, don't you? U to the 3/2. Very good. And then what do we divide by? Just divide by the power. Yeah. So divide by 3/2. Very nice. And then what do I add? Plus c. Very good. Yes. Since it's an indefinite integral, always put plus c there. All right, we're almost there. Yeah, I know. Jackson probably wanted to simplify that a little bit quicker. I was slower. So we have 1/8 times 2/3 times x to the 4th plus 3 to the 3/2 plus c. I can clean that up a little bit so that I get 1/12 x to the 4th plus 3 to the 3/2. It's about the best I can do. Is that what we had on the left? Oh, it is. After all that work, you knew that that was the answer. At least those of you who has the worksheet. Sorry about that, right? Yeah. So there it is. So any complaints about my algebra steps? You're like, where to go? What happened? Why? Maybe you're angry about the way I do this. It's fine. I think just recently I heard someone saying, I'd rather you be angry than apathetic. Was that in chapel on Friday? I forget. Anyway, let's go to last one. Last one on this page at least. And I got this on next one, the bonus one. So let's see how you do with this. See if you can do this yourselves. So first thing is u is equal to what? Then du is equal to what? Then you're going to do some algebra. And then so let's get those two out of the way first. Take a minute, see if you can work those two out, u and du. I know I'm violating, you're like, wait, I thought u was supposed to be the thing in parentheses. There are no parentheses here. Well, there's implied parentheses. So think of it that way, that if you were to type this into your calculator, you would have to use a set of parentheses somewhere. That's the set of parentheses I'm talking about. Yeah, so maybe that's a good way to think of it. If you were going to graph this on your calculator, you have to use this. Well, unless you have one of those fancy front row people, have the fancy ones. Sorry, well, not him. He's got nothing. No graph. It's like the zero graphs on that thing. All right, let's see how we did. Sure, I'm blabbing too much. Leanne, what do you think is in parentheses here? Do you want me to put the parentheses in? The whole thing on the bottom, is that the thing you're saying? Yeah, the whole thing on the bottom, that's right. 2x to the fourth plus 1. So, yeah, what I meant was, like, if you were to type this into your calculator, you would have to do this. X caret 3 divided by, whoops. I might even put a set of parentheses there, because I'm always scared of my calculators. But here's the set that matters. 2x to the fourth plus 1. There. So it's this set of parentheses, the set that is sort of delineating the denominator. Oftentimes this is going to be the case. You're going to have something in a denominator, and you're going to say, hey, there's no parentheses there, but you have this implied set of parentheses. All right, now we need the derivative of that thing. Colton, what's the derivative of this? Ooh, thank you for putting the dx there. Very nice. All right, see if you can do the algebra yourself to get, so here's the goal. 8x cubed dx should be over on the right. You have the integral symbol on the left, and you've got something in between. So I've left some room here so we can do a little bit of algebra. So do this. This equals this, which equals this. So see if you can do the algebra yourselves. And if you're one of these anti-algebra people, you do it your way. Okay, I'm going to do the first algebra step for you, and then I'll find someone to do the second algebra step. So the first algebra step is, I see that there's an x cubed over there, and I want to smash that next to the dx, so that at least I've got x cubed dx. So all that's left is to somehow get an 8, shove an 8 in there. Jackson, do you know how I'm going to stick an 8 in there? Oh, very good. Yeah. So if I put an 8, then I also have to put a 1/8 next to it, right? And then it all works out. So maybe I'll put the 1/8 out front now. Get them nice and far apart. 2x to the fourth plus 1. Oh, that's beautiful. All right, now we do our substitution phase. We're on step 4. So this is going to equal the integral of 1/8. I think you can all handle this. 1 over u du. I mean, the whole point of getting all of that stuff together was so that I could just say, hey, all of that stuff together is du. And then, of course, the dx, that was from the beginning. Ooh, this looks fun. 1 over u? Do you remember 1 over u? Well, I'm sure you do, but you're not here. Raina's here, though. Raina, what do you think? What's the antiderivative of 1 over u? It is. Very good. Now, just so that we're correct, we're going to use the absolute value. What do I have to add to this? Yeah, the plus c. Yeah, so it's natural log of the absolute value of x. And technically, with this problem, you would have been correct not to put the absolute value there. I'll explain in a minute. Because the final step is to resubstitute. And when I do that, you might notice that 2x to the fourth plus 1 is never negative. There is no number you can plug into here to make this negative. And so you don't need the absolute value for this one. But I guess just to be correct and complete, let's go ahead and put an absolute value in there. That's the correct, that would be sorry, I'm mixing my computer's things, WebAssign. The WebAssign correct answer will have the absolute value, even though it's not really necessary. They'll want you to put it in there. Whew. Okay, what are we doing? Oh, that's exciting. We're all done. No, we're not all done. I have this second worksheet to give you some more practice. So here we are. Let me pass this around. 1, 2, 3. Here's 1, 2. I'll put this on the screen for Gavin. Here's 1, and here's 1. Right, there it is. Okay, so I got one extra one. So what we're going to do is we're going to do as many of these as we can, and then you can save the rest for tomorrow. So give me a sec. Let me find the right thing. There it is. So the ones that I want to do, I want to do number 1 because it's fun. I want to do number 5 because it's weird. I want to do number 3. So 1, 3, 5. Looks like it's all the odds. I want to do number 7 because that's really weird. Let's see, is there anything else odd here? The odds apparently are the oddest. That's not bad. Oh yeah, let's do that one. Let's do 11. Yeah, apparently we are going to do all the, number 9. Yeah, okay, so apparently we're going to do all the odds while we're here. And then if we don't have time to do the evens, maybe we'll do those for homework. So start with number 1, work it out, work with a friend. In fact, here, let's just do front page. And notice I've got U and DU already printed there, just to help you to remember you're doing substitution. So if you want to, you can work with a friend. If nothing else, take a guess as to what U and DU will be. I guess it's too early to have to communicate with other humans, work with each other. It's understandable. But yeah, let's work as we're kind of a small group as it is. You know, if this was like in the fall, I had 25 or something in Calc1. This is much smaller. We can just work as one big small group. Let's go ahead and get our U and our DU. And if you don't agree with anything, just chime in. It's fine. Matt, what do you think? What are you going to use for number 1 for U and DU?
U would be 3x plus 6, and then U would be 3 again.
Yeah, very good, very good. So that's what I would use as well. Now we have to do a little bit of algebra, so humor me on this one. I want to get 3dx over here. What's the rest of this thing going to look like? Claire, what would this look like if you moved a 3 over here? So put a 1/3. Oh, you wanted the 1/3 out front. Yeah, that's okay. And then the rest of this stuff is the same. Very nice. Excellent. So far, so good. All right, now we have to do our substitution. So Sam, what does this look like after substituting? Very nice. Yeah, and that's something that now it's much simpler, isn't it? So that's what this integration by substitution really helps simplify doing an integral. Jarrett, what's the antiderivative of this thing?
What?
Antiderivative?
Of what?
Oh, of this thing right here, the last one.
Oh, yeah.
1/18th. U to the 6th. Nice. Plus what?
Plus
Oh, yeah. That's right. I knew there was something missing. So it's so good. You could, if you need to, you could write this as U to the 6th over 6 times 1/3, and then combine the two. And then the final answer, we just go and plug this thing back in. So we got 1/18th, 3x plus 6, sorry, to the 6th. C. Now I need to confess something. If I were doing this without trying to teach any substitution method, I would never do that. That's way too much work. I would go directly from the first step to the last step. I would skip everything in between this. Now, if you're looking at that saying, how? Then it's okay. Do substitution. But I just wanted to give you permission to, when you start seeing the pattern and realizing that, oh, if you have a linear term in here, and it's a linear term to the 5th, then I just do the linear term to the 6th divided by 6, and then I multiply by 1 over the derivative of this. That's totally fine. So, you know, but don't do that immediately. I mean, unless that all made sense to you. So, you know, do this, but like I said, I understand. I don't want to do all that if I can avoid it. So yeah, I would never have written all that down normally. Like in multivariable calculus, I would just be like, yeah, there's this trick we can do. Go directly down. Wow, my Apple Pencil, something's wrong. Okay, let's go down here to this thing. So I don't know if you had a chance to figure out what U and DU are. Let's see who's next on the. Yeah, everyone gets called on multiple times in here because there's so few of you. Sorry. Jackson, what do you think? What is U going to be? Sine of theta, very nice. So that 10 there, Jackson recognized, is actually this. That's what that sine to the 10th means. So yeah, it's that sine that it's raised to the 10th power, but that sine is the thing that we're using for U. Very nice. Yeah, so don't be fooled when you see something like that to think, oh, there is no parentheses. There is, it's just implied. Sine to the 10th is shorthand for sine of theta to the 10th power. All right, let's do our derivative. All right, Raina, what's derivative of sine? Cosine. And then do you know what I tack on to the end of this? Ah, dx or d theta. Yeah, since we're doing theta here, I know, I changed variables on you. But yeah, so since I have theta as my independent variable for this integral, I'm going to use d theta for the substitution. So I think there's a t here somewhere. Isn't there? Yeah, there's a t. So there you would use dt. And if you have a different letter, whatever letter it is, yeah, most of them are x's. There's a t. There's an x. Okay. So far, so good. We're doing great. Okay. What's the correct time? Just a minute. 8:48. That's a little bit slow. My watch is correct. All right, so we're doing great. Let's see what we can do here. Sam, what does this look like after substituting? Don't forget the 10 there. 10th. So I'm substituting. So the sine theta turns into u, and then all of this stuff. I didn't have to do any algebra because I already had it like that. All of that turns into du, doesn't it? Yeah. Sorry, it was too easy. It's like, oh, it's just a direct substitution. Yeah, there's no algebra involved for this. It gives me a lot of joy when I get one where I don't have to do any algebra. It's like, oh, it's perfect. Okay, so now we have to do the antiderivative of this. Colton knows it. What's the antiderivative of u to 10th? Beautiful. Plus what? Oh, yeah. I'm forever forgetting that. Losing points. All right, now I just make my final substitution, resubstitute sine of theta. And if you want to write that as sine to the 11th theta, that's fine. I don't care. But that's it. Beautiful. All right, let me just see what's coming. Okay, that's pretty standard. I know it's kind of weird. But let's just talk about, I want to get to number 7 for sure. So let's just do this one really quick. Or not, we won't finish. We can loop back around if we have time. But let's get the u and the du. So Leanne, what do you use for u for this one, number 5? Excellent. So one way to write the square root of natural log of t is natural log of t to the 1/2 power. So Leanne's kind of zooming in on that. That's going to involve our substitution, and it is just that natural log of t. So you don't need the radical. So there it is. So it's the thing inside the parentheses. You don't need the parentheses. In fact, you don't want them. Because the next step is to do the derivative of that. So my derivative, Claire, what's the derivative of natural log? 1 over t, dt. Very good. And you can see here that this is pretty straightforward now. You're going to have this natural log of t. I'm going to just do the algebra, even though you probably don't need it. 1 over t dt. So notice that you can separate out, since this is a product, 3 times t, and you can kind of see where that's heading. The rest of it is pretty straightforward. So we'll loop around if we need to, but I want to make sure we get to 7 especially. 7 is extra special. Okay, so we'll come back if we need to, but I think that one's pretty straightforward. 7 though, 7, I love it. Let's see if we can do 7. I'll bet we can. All right, Jared, with number 7, what's in parentheses here? 3x plus 6. Excellent. Now do the derivative. Colton, what's the derivative of 3x plus 6? Just 3dx. Very nice. Now we're going to do our substitution. Oh, first of all, the algebra. Let me do the algebra. So let's see what we got to do here. Sam, how do I get 3dx into my integral here? Very nice. So I'm going to put a 1/3 out front maybe. 3x plus 6 to the 3/5. Now we're going to run into a slight problem. It's not a big problem. It's just a slight problem. And that is when we do the substitution, you're going to do this. This thing here will become u. This thing here will become du. The 1/3, it's just going along for the ride. The problem is this thing. That's illegal. Okay, so let me explain for a minute. This is a good point at time to explain that when you get done with your substitution, you should not have any x's left. They should all get turned into u's. That's illegal. I can't have both u and x in the same integral. So if you ever get to this stage where you've done your substitution and there are any x's lying around, or in the case of t, if there are any t's lying around, something went wrong. There are two options at this point. Number one, go back and do a different substitution. If you're pretty sure your substitution is correct, another option is to go back and take that substitution and rewrite it so that I can get rid of x. Now, at first that may seem fantastical, but let me just demonstrate this. What I mean by that is you take this, rewrite it like this. Let's see, you have u minus 6 is equal to 3x, and x is u minus 6 over 3. And using that, I can get rid of the x. In particular, the x ends up being u minus 6 over 3. So I know that that's like another, it just feels like what I've done is I've just taken substitution and I've just made it way harder. But in reality, this actually makes the integral a lot easier. So let's see how this one works out, because now it's not very bad. I'm going to pull the 1/9 out altogether, because 3 times 3 is 9. And then you have u minus 6 times u to the 3/5 du. Put a bunch of equal signs here. So 1/9 integral of u times u to the 3/5 minus 6 times u to the 3/5. And I know algebra is hard. That's actually u to the 1st times u to the 3/5, which is equal to u to the 8/5. 1 plus 3/5 is 8/5. Ooh, we've got 5 minutes according to my clock. It's got the little alarm, u to the 3/5. And then the rest of this is pretty straightforward. 8/5 plus 1 is 13/5. So that's going to be 5/13 u to the 13/5. And then 3/5 plus 1 is 8/5. So that'll be 6 times 5/8 times u to the 8/5 plus c. And then you can go substitute back in for, I guess that's what, 3x minus 6 would be c, or 3x plus 6, was it? Whatever it was, whatever it's supposed to be. Yeah, 3x plus 6. Whew. Yeah, so I guess I'll might as well write the correct answer here. 5/13, 3x plus 6 to the 13/5 minus 6 times 5/8 is 15/4. 3x plus 6 to the 8/5. Sorry about the mess there. Probably I should have just skipped writing it again. Well, in the remaining couple of minutes, let me mention what you would do for this number 11, since it's staring us in the face. Pretty straightforward. U is radical x plus 1. Du is actually 1 over 2 radical x, so you can see where that radical x there is going to be involved with the dx. So that one's not bad. The bad part is you have limits. So here's the deal with limits. If you have limits, you don't need the plus c. And then when you get back to the x here, you can plug those in to the final answer, upper and lower. So essentially you're doing all of this, and then you're plugging in the 4 and the 1 to get your final answer. All right, so I think what I'd like you to do for homework, instead of Sorry, I was just looking ahead at number 9. Instead of doing whatever I've got up there, is do this worksheet. And I will, this time I'll actually upload it so Gavin can use it if he checks. So finish the rest. I know there's like what, 8 or 10. I don't know. We did 3 or 4 of them. So do the rest of them as best you can. Identify U, DU, bring it tomorrow.